with the fact that L vector is equal to I into omega vector is applicable, subject to the condition the body is symmetric about the axis of rotation or the point of rotation, correct?
Yes, sir.
Okay. What if you have to relate angular momentum with angular momentum against center of mass frame is next to be taken. But for that, we need to be aware of what frame I'm into referring. The frame which I am giving an epithet being center of mass frame is a frame which has got origin located at center of mass of a body. Origin of center of mass frame is at center of mass of body taken, body concerned. And if the body is rotating, body will rotate as we are in rotational mechanics. Body is rotating, let's say, center of mass frame is not going to, or the axis of center of mass is not going to change its orientation. Is
Yes, sir.
rotating, let's say there's a ball is rolling down an inclined plane. Center of mass frame once fixed. See, the axis to be fixed is as per you.
Yes.
But once it's fixed, the axis is not to rotate with the body. Got it, dear? And this is what I was coming to the other day, if you can recollect, Vasudev, when I told you that there is a ball which is rotating and there is center of mass frame.
Yes, sir.
Now the ball is rotating and the center of mass of the ball is moving in a circle.
Yes, sir.
Then there are two rotations which you will get. Two rotations vis-a-vis center of mass frame. Are you able to comprehend those two rotations? See, what I'm saying is there's a ball. Now the ball is rotating about an axis.
Yes, sir.
So the ball will rotate about an axis. Now the ball is to rotate about it, the axis which is fixed to center of mass or let's say the center of the ball per se, correct?
Yes, sir.
Getting it? And that rotation, are you able to comprehend? Assume that there's a frame which is fixed to the body being ball over here, and the origin of this frame is at the center of mass of the ball, fine?
Yes, sir.
So that means the center of the ball, right? This is a symmetrical body, correct?
Yes, sir.
Now, if there is an axle about which the ball is rotating, forget about the stationary frame, the so-called stationary frame, which is fixed to the axle or the shaft. I'm not referring to, if I may draw this a minute. So this is the ball. This is the ball which I'm referring to, Vasudev, and this is the frame. This frame, I'm not to pay heed to. Ball is rotating this way, right?
Yes, sir.
So this is what I have called shaft, fine? Now the ball is rotating this way, this frame is fixed, the y-axis fixed, this is the impingement in the ball, this is impaling, this rod is impaling ball, let us say. This is the x-axis for now, when I have frozen it, fine, dear?
Yes, sir.
Now if the ball is rotating and you are now on center of mass frame, so let me show you the center of mass frame as well. This is the center of mass frame, okay? Getting it here? The right one. Center
Yes,
of
sir.
mass frame, clear?
Yeah.
Now, if I'm on the center of mass frame, then I get to know two rotations. Are you convinced with it? I get to see two rotations when I'm on center of mass frame. Are you convinced with it? Yes or no? Think about it.
Rotations, how? If it... Okay, I think I haven't gotten the complete picture here. Right now, the way I see it, the ball is rotating about the x-axis. Is there anything else that's going on?
Yeah, the ball is also rotating about this axis. I told you that I'm not to change my orientation. That is what I wanted to inbuilt. And I want to nip all the doubt in the bud. What exactly is center of mass frame? You are on center of mass frame. You will not rotate. Your axes are fixed. So if you are looking at me, right?
Yes.
Let's say you are looking at the screen. You are looking at the screen and the body is rotating. Fine, dear. You're looking at the screen and the body is rotating. You don't change your orientation. So, would you
Yes, I
not
get that.
see the body rotating about this axis?
Yes, sir, you would.
Would you not see to be rotating?
If your
The
coordinate
body,
axes are fixed to the ground frame, then yeah, you would see it rotating.
it is not only rotating about that axis, but also is rotating about the other axis.
Yes, sir.
Convinced?
Yeah.
So there are two rotations which we have to take into consideration. One, I presume, was clear to you. That was amply clear about x-axis. You'll see it rotating. And the other one, which generally is not clear to the student, is about the axis which I have ticked. So you're upticking on it, right?
Yes, sir.
Okay. These two rotation, and the third one, of course, the center of mass rotation per se, right?
Yes, sir.
Which is as seen from the ground frame. Getting it? Yeah.
Yes, sir, got it.
So this is what we'll have to take into account whenever I am on center of mass frame. Then A, it qualifies to be called center of mass frame when the origin is at the center of mass of the body, and if the body is rotating, then center of mass frame will not change in its orientation in coordinates. Fine.
Yes, sir.
These are the prerequisites required, the only two prerequisites required for any frame to be given the nomenclature of a center of mass. Having said, we move forward. What I'm to do now, I'm to relate angular momentum of a body with angular momentum calculated about center of mass frame. Is it okay, dear?
Yes, sir.
Angular momentum of a body about any frame. Take any frame, and angular momentum of the body calculated about center of mass frame. These two I am to relate. Very important relation. Again, I don't want to be hubris, but you'll not be sounding hubris, but I'll not be falling short of stating you will not be getting anywhere. And you can check the veracity of my statement later. Now, what I'm trying to suggest over here is a relation which they do use. Of course, they are no novice. They do use this relation, but rare is being this relation executed. So we are trying to execute the relation per se. And for that, what I do, I take an irregular shaped body. So I take a whiteboard, a new one first. Okay, this is a new device for me. Need to check what to do. I'm not using tab today. How to get another board here?
Sir?
There's only one symbol over here. Whiteboard is what is showing. Opening a whiteboard will stop the screen share. Do you want to continue? What it's saying?
So yes, I think you have experience with the inbuilt whiteboard in Zoom. I think you'll be able to work with that.
How will I get a new whiteboard?
So the way
How will
you
I get
got
a
it on
new
your old
whiteboard
device,
here?
it should be the same process.
No, it's not the old device here. This is I'm working on a cell today. Nevertheless, let me see what can be done best with it. Yeah, got it. Yeah. New whiteboard. Yeah. Okay. So this is the one with us. What we do now, I'm taking two framed here. You'll have to bear with my handwriting today as I'm not using stylus. This is one frame, this is the other frame, this is center of mass frame marked S prime. We use prime in general for center of mass frame. This may be the body, whatever it be on shape, regular, irregular. That is for us to decide. This is what to us, this is RCM to us. RCM, I presume, is center of mass position vector, right? Yeah.
Yes, sir.
Of mass position vector. This is ith particle as located from S prime frame. S prime is center of mass frame. So I write Ri prime for it. Okay.
Yes,
Ri
sir.
prime. And this is what to me? This is R to me. This is Ri to me. Find here. So we know the relation between RCM, Ri prime, and Ri. Correct? We can say RCM
Yes, sir.
plus RI, RCM plus R. You can comprehend it as I ask you for an excuse on the right. So RCM plus RI prime is what to us? Is
All right.
RI for us, correct?
Yeah.
Okay. So this is what we are getting. Now what we have to calculate is L. We have to calculate L. L about O. I have to calculate angular momentum of ith particle about O. Okay, dear?
Yes, sir.
I repeat, angular momentum of ith particle about O. Right, dear?
Yes, sir.
Clear, Vasudev? Okay. So what will be angular momentum marked as? Angular momentum of ith particle, if I write it down as Li, what will this be marked? This will be marked as Ri, correct?
Mm-hmm.
Cross mass of ith particle into velocity of ith particle. These are all to be calculated vis-a-vis S frame, correct?
Yes, sir.
Okay. Now what next we can do is very obvious. I have to factor in center of mass. So how can I factor in center of mass? By making good the equation at hand. And the equation reads RCM plus RI prime is equal to RI. Correct, dear?
Yes, sir.
Okay. So suggest me the way by which I'll be able to factor in. And please keep it in mind, I'll be using a very important relation, Vasudev. If you're aware of it, well and good. If you have not been yet updated on it, let me do the needful, which is MIRI prime square. What will it be? Could you please tell me? Let me ask instead of uh, any help, any aid unsolicited. If you require, I will definitely provide, but wish you get it on your own. Question being, can you tell me what will be summation of MIRI prime for any system? MIRI prime for any system.
So would it be the moment of
Think
inertia
about it, you'll get
of
it.
the system about its center of mass?
What
I
is the
mean,
summation of MIRI prime? By the way, prime I use for positioning vis-a-vis center of mass frame. I
yes,
think
sir.
I made my point clear.
Yeah.
Okay. So R1 prime is position vector of first particle as seen from center of mass frame. Same interpretation goes for any particle you take. Clear, dear?
Yes, sir.
Okay. So what would you get summation of MIRI prime equated to? This is the question. Summation of MIRI prime according to you will equate to
Um, so
quantity.
if
What
RIs were,
mathematical equation?
so I didn't catch what you said. Could you repeat?
What will be summation of MIRI prime for any body where RI prime refers to positioning of particles of the body or the particles that the body comprises of vis-a-vis center of mass frame? That's
Yes,
it.
sir. So I was saying, if the RI primes were measured from a particular axis, then you could correlate that with the moment of inertia with respect to that axis, right? But they're measured from the
We can
origin.
correlate. We can correlate, but wish you take a step back and take a leaf out of your center of mass calculation, please. Center of mass calculation, if you may relate it to. Must not have lost on you, center of mass, right?
No, I do remember it, but I do remember that it was
Center of
MIRI there,
mass for
not
anybody is
MIRI
pretty simple, yeah.
squared.
Yeah, correct. No. Center of mass doesn't have square in it, yeah.
Yeah,
Center
that's
of mass
precisely
for a
what I said.
body is, yeah, what did he say?
So I said that the squares didn't exist there, so
So square doesn't exist here either. I'm not in odds with square not existing over here. As square doesn't exist there, it doesn't here. I'm asking for summation of MIRI.
oh, okay. I'm sorry, I must have got that wrong.
RI prime, I said. I didn't say square. Summation of MIRI prime. Did I say square?
No. I must have got it wrong then. So
Summation of MIRI prime. What will it be?
summation of MIRI prime. Well, it should be zero, right?
Exactly. Good.
Yeah.
Similarly, summation of mi vi prime 0,
Yes.
summation of mi ai prime 0, right, dear?
Yes. Yeah. Yeah.
If this being known to you, Vasudev, then my work is almost done. Why? You are now to replace for Ri and Vi. Please do the needful. Instead of Ri, what you use is RCM plus Ri prime, correct?
Yes, sir.
Instead of Ri, you use RCM plus Ri prime. And instead of Vi, you do VCM plus Vi prime. Fine?
Yes, sir.
Okay. Expand and see what you get.
Okay.
Expand and see for yourself what you're getting.
So you get mi times ri minus rcm summation is equal to 0.
Yeah.
So summation mi ri
The two
minus.
factor, if I use RCM plus RI prime plus RI prime,
Yeah.
right? Crossing it with mass of the particle was Mi, so Mi is what I'm using over here, and
Yes.
VCM being VCM plus VI prime being V replaced by VI replaced by. Okay, this is
All
what we
right.
are getting.
Yes, sir.
We have to sum it over. You're aware of it. Next, I'll be going for the summation. Correct?
Yes, sir.
Isn't it?
Yeah.
So when I'll go for summation, RCM plus MIVI prime. So when I'll go for summation, then there are a few factors which will turn out to be 0, correct?
Yes, sir.
Precisely 2 factors will turn out to be 0, right?
Yes, sir.
And we'll be left with which factors? First one being MI, summation will fall on this term, right?
Yeah.
And RCM cross VCM will be left with, right? This will be left?
Yeah.
Okay, and will be left the other one, which is summation, all factor having I in it, Ri prime cross Vi prime, correct?
Yes, sir.
These are 2 factor left, and you are aware of what to call the first one and what the second one. Second one is certainly all reference with center of mass frame, correct, dear?
Yes, sir.
So that is nothing but angular momentum as seen from center of mass frame, correct?
Yes, sir.
And the other one is M into or RCM into M into VCM, right?
Yes,
The other one is RCM into M into VCM. And for that, what we state is it is a fictitious particle having entire of its mass located at center of mass. So you have taken a body, entire of the mass of the body is located, is positioned at this fictitious particle. And this fictitious particle is having its position at center of mass of the body and moving with a speed equal to that of center of mass, right?
Yeah.
So first one is angular momentum of a fictitious particle with a mass equal to that of the system per se, located at center of mass of the system and moving with a velocity equal to that of center of mass of system concerned, right, dear?
Yes, sir.
We'll be using this. This is symbolically represented as L is equal to LCM plus R cross M VCM. L is equal to LCM plus R cross M VCM. This is how we indicate, and there are many a problem which you'll be getting on this concept. For instance, I present one to you. This is a frame and a body is rotating, moving with velocity v, rolling without slipping, let's say. Mass of the body m, it's a sphere. You have to calculate angular momentum about this point. Tell me, how will you be calculating about O? Angular momentum about O. There's a sphere, solid sphere rolling without slipping, mass m, radius r. You have to calculate what will be its angular momentum about O.
Yes, sir.
How do we go about it?
Yes, so the
Simple
angular
now.
momentum of the center of mass about the origin is constant since it's moving in a straight line.
Angular momentum is constant, correct.
And then the angular momentum of the sphere about the center of mass can be easily calculated with the general formula I omega.
I into omega straight will be used, right, dear?
Yes, sir.
We can straight away use I into omega and we can calculate it. As per the body, any frame which is fixed to the body, it will be I into omega easily calculatable. and
Yes.
the other one we can use by the formula which we have derived a minute ago,
Yeah.
right?
Yeah. Yes.
Okay. Now there's a concept which is of ICRD. ICR, instantaneous center of rotation. That means for that instant, all the points are at rest. So it can be instantaneous axis of rotation if you have many a point. And if there is only one point which is touching the ground, we assume it to be IPR, instantaneous point of rotation. Okay, dear? Or
Yes, sir.
center of rotation. India?
Yep.
Here, if I am to calculate angular momentum of this body, let's say about any point, I have taken point O. Instead of point O, I wish calculate angular momentum about this point, the point which is touching the ground, P. Okay? Angular momentum about P. So I'll have to use again the same formula, by the way, Vasudev, because I don't have any other formula as of now. We'll be deriving maybe. You may say that I'll use IP into omega, but I have questions and I am to protest it. How can you use IP into omega? We can use IP into omega if this point is P. We can use IP into omega if and only if the body is rotating about, which is what we have proved, by the way, as of yet. That is, the body is rotating about an axis, correct, dear?
Yes, sir.
Okay. This axis is not inside of the body. So I'll use L is equal to LCM plus R cross M VCM. And when you use it, of course, you will be getting it as IP into omega. Okay, dear? There'll be no
Yes, sir.
exception to it. If you use IP into omega right away, then I'll ask you to define omega. What is omega vis-a-vis this point P? We know that this point is instantaneously at rest. So we can assume that about this point, the body is rotating. Correct, dear?
Yes, sir.
The body is rotating about this point, and if it is in pure rotation for that moment only, if it is in pure rotation about this point, then I can straight away use which equation? IP into omega, correct?
Yes, sir.
You're absolutely right on it. Let me skew it slightly for you, which is the body is not rolling without slipping. Omega is not related with V as V is equal to omega R. It is something else. V is equal to twice omega R. What do you do in that case?
So then you adjust P so that so I mean, it'll basically either go vertically up or down depending on the relative
Are you
values of
sure that
omega.
if you will adjust, fine? Let's say I have got ICR over here, fine.
Yes, sir.
Let's say I have used 2 omega R, I got ICR over here. What do I do next in order to calculate angular momentum about this point?
The same formula we've been using so far.
Can we use IP into omega?
Yeah, if we were able to use it in the previous case, I'd say we would be able to use it here too.
Are you sure? Will you reevaluate? This P prime, let's say, the new point P
Okay,
prime.
yeah, wait.
Can I use
Omega will
IP?
change. Omega will not remain the same.
What is omega? Omega is not defined vis-a-vis this point, right?
Yeah, we'll have to
How will it
reevaluate.
define omega?
Uh,
P you can define, of course, but P prime, how will it define?
um, okay. It is rotating about its center of mass and also rotating about P, so that essentially two omegas here.
Yeah.
So yeah, I think
So
we'll have
which
to stick
formula will have to fall back to?
yeah,
L is equal to
LCM plus
M plus R cross M VCM, right? Yeah.
yeah,
That's the formula will have to fall back to.
yeah,
And that'll be simple. Pretty simple then, right?
yes,
Correct?
yeah,
So IP into omega has got limited uses. It cannot be used at all the points. Yes, it can be used when you're inside of the body or at instantaneous center of rotation. Correct, dear?
yes, sir.
Okay. In either of the case, we are happy users of the formula. And otherwise, we are to fall back to certainly this formula L is equal to LCM plus R cross M VCM. Said that, let's move forward with few questions. Shall we take a few questions? One
Yes,
very
sir.
patent question of, or is question which is also found in the Revit books. being the question of top. They'll get your top, it's rotated about this axis, and the top center is rotating is with omega prime, and the top is rotating with omega, let's say. Then they ask, find all the terms are given to you, angle of inclination of the axis given to you, alpha, let me mark it to you. Let's say this is alpha given to you, r given to you, radius given to you, L given to you, the slant length given to you, L. They ask you on angular momentum, they ask you on torque. What is torque? What is angular momentum? About point O, this point O. At times do ask. Okay. And the other question, which is also there, very pertinent, is they'll get your rod with certain angle alpha, and we'll say that initially alpha is 0. The rod starts slipping against vertical wall and horizontal floor, both being smooth, mass length being accorded. Find the angle at which rod will leave contact with vertical. At what angle the rod is to leave contact with the vertical, with the wall. These two are, I would say, few of the questions which do pique interest and motivate student towards such topic, which is of great import to any teacher, as it is very high on weightage vis-a-vis marks, and it has got at many a place in physics implication till this level. Till this level means till 12th.
Yes, sir.
So what exactly comes to you? I've solved these questions, I've tried them,
So I definitely
or
have
just
solved them.
skim the surface?
Yeah, back in grade 11.
Okay, you have solved?
Yeah, I've solved them.
Okay, that's good. Solve on your own or taken the class?
Um, I think the one on the right, the rod question, that was taken in class. The left one, however, I
Okay,
solved on my own.
okay. So the right one, what is the process that you have adopted?
So I don't quite remember. I'll have to revise it.
Okay. Was there anything related to ICR?
Again,
Instantaneous center of rotation?
as I said,
Or the
I
rest
do
of
not
it?
remember the process that followed to solve
Okay,
it.
fine. 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 We'll be solving by many a process. That's the reason I did ask this question. Nevertheless,
Yes.
I'll get you time to recollect, right?
Yeah, yes.
Okay. Okay, the left one?
That one, it's in my notes somewhere buried beneath the textbooks. I'll have to look it up again.
Okay, fine. So you require a few questions which you are not being acquainted to as yet? Okay, dear, I'll get you one. Let's start with a few. We have many up our sleeve, and this will help you in understanding ICR as well. In case in 10 minutes we do have, if it gets lost, then I'll be connecting if I'm not able to finish it up in 10 minutes. Okay, dear?
Yes, sir.
Now look at this, Vasudev. What I'm next to say is, there is a rod, Vasudev, which is hinged. Let's say, let me take a page. There's a rod which is hinge over here. We'll be developing a formula over there, and I'm ascertaining you this formula you have never come across. Let me check on the vindication, and you will be the one to vindicate. This is the point about which the rod is in. Mass of rod is m, length is l, f is the force, Vasudev, which is impulsive in nature. You can mark j or f into delta t, whichever you want. What I wish to ask is, can you tell me what should be the relation between, I write a and b to make it generic. Over here, a and b are same, by the way, which is equal to L by 2, correct? Because I'm hitting at the end.
Yes.
So a equal to b equal to L by 2 for this case. Nevertheless, a is the measurement of hinge point from center of mass, and b is the measurement of point of hit from center of mass. Got it, dear?
Yes, sir.
Okay, when you make a hit, there will be some reaction at the hinge, correct?
Yes, sir.
Okay. I want you to relate A to B so that the reaction in x direction equates to 0. The component of reaction in x direction equates to 0. I don't want to do much with y as of now. I just seek Rx should be 0. So how A, B, and K being radius of gyration, are related to each other if we seek Rx equation to 0? I am to
Sir, I can't hear you. Excuse me, sir. Can you hear me?
Yeah, Vasudev.
Yes, sir.
Yeah, tell me how to relate. I think the video must be on, right? Yeah, because I got a call. I took the call. Please check once.
Yes, sir, it is.
Okay. Can we relate, Vasudev? K, the rate of gyration with A and B. And this formula is going to go a long way in serving the case for instantaneous center of rotation. Are you there?
Yes, sir. But I lost you for a second. Could you just repeat the question? I mean, I got most
This
of it. I
formula
got
will
what
go a
A and B
long way
is.
in serving. Yeah, A, B, R, these are the ones. A, B, R, you can write that down. Both are measurement vis-a-vis center of mass. A being, and they are interchangeable by the way, A being the reaction as measured from center of mass, and B being the point of impact as measured from center of mass. Fine?
Yes, sir.
Okay. How they relate against K square or K being radius of gyration. So what we do, we write equations. Shall we write equations, Vasudev?
Sure.
If I am to write equation, the first equation vis-a-vis center of mass movement linear is Frx delta t dt, right? This is
Yes, sir.
impulse in x direction that will equate to mvcm. Fine?
Yes, sir.
Okay. Now, the impulsive torque. What impulsive torque get me is Fa plus b dt, right?
Yes,
Fa plus b dt, what is this to me? Is I about p into omega for me, right?
yes, sir.
Getting it? F minus Rx, the first one being for center of mass motion in linear direction, second one being the torque equation, the rotational motion. Accordingly, we are to get value for F. If I am to divide them and take Rx is equal to 0, we'll be able to relate A to B, correct? IP
Yes,
can be written equal to what you are well aware of. IP can be marked as
L
mk
square.
square plus ma square, correct?
Sir, could you come again?
IP can be marked as mk square plus ma square, correct?
Yeah.
IP, this point P for me, right?
Yes, sir.
I have to pitch in K, right?
Yeah.
I have to rope in K. So to rope in K, I'll replace IP by M bracket open K square plus A square. Omega and V are relatable. You're aware of it, right? VCM is equal to A into omega, correct?
Yeah.
Please do all the replacement. Place Rx is equal to 0. That is what the objective. And let me know of relation that A and B share with K. Please do the needful quickly.
So, yes, the
You may
problem
divide
is,
the two to get rid of F and delta T.
I
Divide
do.
2, take Rx 0.
So the problem is I do not have any writing material where I am right now. Nah, won't be able to go
Okay,
back
so
inside.
we'll divide and we'll. Okay, you'll do the needful. You'll get to know then
Yes, sir.
how to
I'll
get
do
center
it
of
after the
mass,
class.
or what you'll be getting. I'm letting you know. You'll be getting k square is equal to ab. Write down k square is equal to ab. This is something which is out of the box, or I would say a shot from blue for a shot in your arm, you say, or a shot from blue, you say. That is up to you to note. K square is equal to ab. To me, this will work. A huge shot in arm. K square is equal to ab. And
Yes, sir.
also should be shot out of blue for you. Are you? If you are through, then I have to eat my words. We'll eat it as a humble pie. What do you know into this?
And this one, I mean, I might have, I might have forgotten it, but I'm reasonably confident I haven't heard of this before.
Okay, k square is equal to ab is what you'll be getting, right? Yeah.
Yes, sir. Okay.
And how does it work? If reaction is zero, Vasudev, then that point will have no acceleration, correct?
Yes, sir.
Though momentary, but there'll be no acceleration. If there is no acceleration, then whatever was the state of motion remains, correct?
Yes, sir.
If the body was at rest, or the point was at rest, it remains at rest. Though for that moment, but it remains at rest, correct?
Yes, sir.
These are the points which are supposed to be held by us when we are trying to nail something by uses of hammer or hit particular shot in lawn tennis. Why I'm referring to lawn tennis? In cricket, somehow you'll be able to save your wrist if you're not holding at the correct position, but lawn tennis impact is very high. So you run a risk of breaking your wrist.
Yes, sir.
So we hold the racket at a position where we get least the jerk or zero the jerk, correct? Yeah.
Yes, sir.
So these are basically what position? The instantaneous center of rotation where the reaction is zero.
Yes, sir.
Where the reaction is zero. Okay, and we get it by k square is equal to ab. How to use it right away? Very simple case. There is a table. On that table is placed, let's say, a rod. Rod is hit anywhere. You want to find mass m given, L that given. Wherever it is hit, to begin with, let me say it is hit at the Yeah, what's there? So it is hit at one of the ends, right?
Yes, sir.
Can you
Yeah.
recording on, right, Vasudev?
Yeah, it's still on.
Okay. It is hit at one of the end, right, Vasudev? So if it is hit at one of the end, then according to you, where will one of the two ends? Then where will lie ICR? Where will the reaction be zero? It's placed on a horizontal table, smooth horizontal table. Where will the reaction be zero? At which point the reaction will be zero? Or in other words, if I am to rephrase, will ask, where will lie instantaneous center of rotation? Where will lie instantaneous center of rotation? Very simple. What I'm to do, I'll be using k square is equal to ab, right? Yeah.
Yes, sir.
This is the point of hit, and which is to me serve ICR, where reaction is supposed to be zero, Rx zero. Ry, no concern over here. It's put on a horizontal, placed on a horizontal table. So we wish Rx to be zero, correct?
Yes, sir.
Okay, k square for this rod, L square by 12 is equal to AB. I don't know what is B, so I'm marking it as X, or I don't know what is A, I'm marking it as X. And the other one is known to me being L by 2. So it'll be X into L by 2, correct?
Yes, sir.
We get X from here. X is equal to L by 6, right?
6.
Yeah.
Yeah. Yes, sir.
So that'll be the position of ICR. Similarly, the other question, which is also to be seen in SE Verma, but we are solving it by a different methodology. I'll be using the other methodology when we are through certain portion. For now, by uses of k square is equal to AB, tell me where should I hit with a cue a billiard ball? Where should it be hit? The billiard ball with the help of a cue to get the reaction at the point of contact nullified, reduced to a naught. I don't want any reaction over here. Where should I hit? Where should I make a hit?
So where don't you want any reaction?
By Q. There's a Q. I want to hit it horizontally. Where should I make a hit so as to get at the point of contact reaction reduced to 0? No reaction there.
Yes, sir. So, I mean, we can use the same formula, right? K
No
squared is equal to AB.
reaction. No reaction, of course, relates to no friction being there, correct?
Yes, sir. And if
Friction
there's
is
no
the only
friction, that point
reaction
shouldn't
that you,
want to move. So,
yeah, there is no friction.
yes.
There is no friction doesn't mean there's no friction on the table. There is certainly friction, otherwise pure rolling will never take place. There is no
Yes, sir.
slipping at that point.
I
No
understand.
reaction means there should not be any reactive force. There should not be any impulsive friction.
Yes, sir. I got it. So, I mean, we can use the same formula. K squared is equal to AB. B would be the radius, A would be the distance of the line of action from the center of mass.
We will be using that and we'll be getting from there what the equation is. The other way by which they solve in, or the other way which we can use, if that is not known to you either, is if this is the ball, this is rolling, this is a V, I want it to roll, I have hit somewhere and I wanted to roll without slipping, then what do we use? We use this way also. We write torque equation and we write force equation vis-a-vis momentum, correct? What will be force equation against momentum? We write two equations, remember. In order to get friction, friction is a very important factor in rotation. If you miss on direction of friction, all the equation will go topsy-turvy, complete haywire. So we need to ensure the direction of friction, in which direction friction will act. And how do we ensure it? We ensure it by the way that I will be executing A and the way that you have executed B earlier, which is reaction. If not reaction, how do we get to know? I don't know the direction of friction, so I'll assume there is no friction acting initially. Fine, yeah.
Yes, sir.
We begin with let there be no friction acting per se on the body. And then we write our equations. We write our equation, or I write my equation against force which I have applied. Now, force being applied, what we will do, we'll write torque equation being at center of mass, right, Vasudev?
Yes, sir.
So first equation will be F into X is equal to I naught into omega, right?
Yes, sir.
F into X is equal to I naught into omega. Let us take this body to be whatever it may be. We can take a general equation. If I want to formulate a general equation, I'll take it as mk square. If not, we'll take the body as a solid sphere, or sphere, as we don't say solid, sphere. So 2 by 5 mr square. I naught is 2 by 5 mr square, right, Vasudev? First equation is this to read, correct? F
So,
into X is equal to I naught into omega, right? Yeah. Getting it?
yes, sir. Yeah.
Okay. Second equation is what to read? Force is equal to mass into acceleration. That also is known to us, correct?
Yes, sir.
F into X is equal to I into alpha, by the way,
Yeah, that's
not
what
I
I was
into
wondering.
omega, right? Sorry.
Yeah.
Okay, okay, right, correct. So this is what the first one is to read, and the second one, F is equal to what to us? Force is equal to mass into acceleration, right? Yeah. So m into ACM, right?
Yeah.
Okay. Now what next? What next can we use if it is rolling without slipping to exhibit? We can use ACM is equal to
Alpha by R.
R alpha.
That's R alpha.
Yeah, R alpha alpha.
Yes, sir.
ACM is equal to R alpha, correct?
Yes, sir.
If it is to roll without slip, correct?
Yes.
Okay. What will this get us? This will get us X, right? Yeah.
Yes, sir.
So we'll get X and we'll accordingly be able to know that what is X. Rather, if it's X given to us, then what we'll get? Just a moment. My aim was to get direction of friction, by the way, over here, correct?
Yes, sir.
So it's not about X. It's about X being given to you, fine?
Yeah.
X being given to you. And then you have been asked direction of friction. What will you do in that case? Then we cannot use ACM is equal to R alpha. Then we'll have to see ACM is greater than R alpha, less than R alpha, or equal to R alpha. Getting the idea?
Yes, sir. Based on that, friction will either act forwards or backwards.
Yeah, based on that, if ACM is equal to R alpha, friction will not act. If ACM is greater than R alpha, if ACM is greater than R alpha, then friction will act in which direction? Think about a situation wherein you got ACM greater than R alpha. So friction will act in which direction?
So 1 second.
ACM forward, R alpha backward, ACM greater. That means the tendency is to slip forward, right? So friction will act in which direction? Backward direction, correct?
Yeah.
Right? At the point of contact, backward. Getting it or not?
Yes, sir. Got it.
Okay, so let me optimize this problem, this theory rather, or problem, fine, the problem as well. Let me optimize it by asking you on a hoop, a ring of mass and radius r, force acted top, horizontal. Friction will act in which direction here? A ring of mass and radius r pulled from top, friction will act at bottom in which direction? Sure?
Yeah.
Think about it, yeah.
Yeah, I'm pretty sure.
It won't act there. It won't act per se. No. Check it. Fr is equal to mr square into alpha. And
yes.
F is equal to m into A, correct? So you got A is equal to R alpha, right?
Wait, you're using a ring? I didn't know that. Okay. All right, yes.
I said a ring hoop.
Okay.
I correctly marked it, ring a hoop.
Yes.
No obfuscation there. Okay. So A is equal to R alpha is what we are getting there. For you're aware of what will be the end result, right?
Yes, sir.
Okay. Now, the problems which we are to solve, there being quite a number of problems that we are to solve. I'll take a few, and it will be based on energy, because energy, when is incorporated with ICR, then the domain of questions certainly do expand. So I'll be taking the energy factor. What are the energy associated with the body which is rolling with slipping, without slipping? But before going into it, one problem which is being for quite some time with me, may you help me on this, is there's a plank of certain mass m, and there's a body of certain mass m to m, whatever you want to take. You can take same mass, no issues. Body rotating, moving with velocity v, or dropped from certain height. It's to hit the plank. Plank has got certain friction mu, friction coefficient mu, and it is kept on a smooth surface of mu is equal to 0. Now, Vasudev, you ought to understand that when a body hits, let's say it is hitting grass, it is hitting floor, whatever it may be, then there can be two situations. Coefficient of restitution given to you have. There can be two situations, Vasudev, right? That the body left ground without slipping. That can be situation one.
Yeah.
Right? It hits, it leaves. Situation two, body leaves after slipping, correct?
Yeah.
Slips, then body is to leave. There's no two way about it, correct? E is equal to half. If it hits with V, Then in perpendicular direction, it will be v by 2. Horizontal it may gain, and accordingly we know that the motion of the center of mass will be parabolic and all. I'm not going there. Fine there.
Yes, sir.
That is not where my doubt lies. Where it lies is body will leave. Will the body leave after slipping or will leave without slipping? How can I make this distinction? How can I make this distinction
So you can
against
compare the
parameter mu?
velocity of the bottommost point of the rotating body with the velocity of the plank. If they match, then they won't slip.
So could you please tell me for what value of mu or beyond? You know that if mu is very high, then you will resist or arrest slipping, correct?
Yes, sir.
Problem may arise when mu is less than certain amount, certain value, right?
Yes, sir. Even if mu
So
is
I'm
0
leaving
and
this.
they're moving with matched velocities, even then they won't slip, right?
Mu is 0, then it is bound to slip, right?
So no, like if the ball is rotating with omega and the plank is moving, let's say to the left with r omega.
Plank is not moving. Initially, the plank is at rest.
Like I'm saying, if the plank is moving, then they won't slip.
Then it's fine. If the plank is moving, then what? Then there is a possibility that mu 0 also will hold, right? But
Yes,
if the plank is at rest, then mu 0 will not hold because the plank will not get impulse to move per se.
yes, sir.
So the body is bound to slip, correct?
Yeah.
Body will leave, but is bound to slip, correct?
Yes, sir.
So what should be the boundary, the threshold for mu? It's subject to body used. I get you over here that liberty. It's a sphere. For a sphere, what should be the threshold for mu to arrest slipping? Getting it?
Yes, sir.
That is what is being asked. So this question, think about it and get back to me on it, right? Yeah.
Yes, sir.
I think you're clear on what I have asked.
Yes, sir, I'm clear.
Okay. Think about it. You can think it now. By the time I'm thinking about the question, which I can draw on table for you. I'm trying to draw on table a few questions. Think about this one. What? How will you go about it? There was one question it just slipped off my mind. See, there are many questions other than these which may catch your fancy, Vasudev, and the one being just to think about it, food for thought. That if you are rotating a coin, Vasudev, right,
Yeah.
and you apply a force, then you don't find it to be toppling that easy when flat. If the coin is kept static, it's
Yeah.
kept on the edge, static, you apply force, it flattens, correct?
Yes, sir.
But when you roll a coin and you apply force, then with the same intensity, it is not to get flattened.
Yeah, same thing with the top. Yeah, kind of stabilizes
So
itself.
why is it so? Why is it so? What torque? How which I'm applying force, I'm applying torque. In first case, it responds to the response to the torque is apparently seen. It flattens, correct?
Yes, sir.
In second case, what happens to the torque? If it is not getting flattened, what is balancing that torque? How is that torque getting balanced?
Um, I guess this got something to do with how gyroscopes work. I remember reading about it, but
Okay. Yes, you must have seen a video as well of that physicist who is very pronounced. What does happen? What is the case? How the
you've
body move?
you've seen
I've,
Walter
I've
Lewin's
lost
and
on his
Richard
name.
Feynman's lectures on it.
Yeah, Feynman, no, not that person's lecture. There's another who is into experimenting,
Walter
much
Lewin.
pronounced on net, maybe. So he has shown what exactly is taking place out there, what is balancing the change in torque. If I'm even if I'm changing torque, let's say I have taken torque to be constant. So if the torque is constant, what is getting balance to balance? And why is it not a possibility when body is not in rolling motion? Think about it. I think this may pique some interest,
Yes,
merits
sir.
some consideration of yours before we discuss in class.
Yes, sir.
Or you want to discuss it right away?
So I'll work on it. We can discuss it in
Whatever
the
you
next
take.
class. I'll bring it up.
Okay. Okay. Question was coming to me. I just lost on what was that question about? The other one which is there over here. Okay, that's I think I recollected. Yeah. I recollected. S.C. Verma, there is a question here. There's a question in S.C. Verma. And he has said that there's a sphere which being left to move down an inclined plane. Okay, dear.
Yes, sir.
And for a sphere, now I'm not going into the rotate and mechanical because that is not what Vasudev relate to. The mechanicals, the rotates. So I am just to get you the formula which we do have for acceleration to roll without slip. I think you must be known to it. What is that? A is equal to how much?
It's the
Lost on
simple
it.
version.
Sine theta divided by 1 plus k square by r square. Okay,
Yes, yeah, I
Vasudev,
remember
this
it
is
now.
not going anywhere. No. I won't take this, Vasudev. Please. Okay.
I haven't revised rotation motion yet. I'm doing it. Rest assured.
Okay. D sine theta 1 plus k square by r square, right? Yeah.
Yes, sir.
This is for ACM. So if a
Yeah.
sphere, you will be getting 2 by 2 tan theta by 7. Fine, you can play the value 200. Now, what did Asivama say? He said that it is half of it. Mu that is being accorded to you is half of what required for pure rolling. Okay?
Yes.
It's a question of its kind, which I have found only with Asivama, unique of its kind. Why I do say this gets you an insight on how can we, with certain precision, dissect between pure rotation and rotation with slipping. And not only that, we capitalize on it to get the amount by which the body has slipped, though we know that they are not separate identity. They are happening pari passu. Yet we are able to find for what distance the body did slip and for what did it pure roll. So that's the beauty of this question. He says that it is not 2 tan theta by 7, it is tan theta by 7. And then go and ask, find the length body did slip and the length by which it did pure roll. If it moves down, if the center of mass,
So you're breaking up.
got it here? L, then for what body must have slipped and for what length it did execute pure roll. Getting the question?
Yeah, could you repeat the last statement again?
For what length did the body exhibit pure rolling and for what length it did slip? Basically, the ratio is what he has asked. L is the total length by which center of mass moves down. So what is the ratio of slip against pure roll?
Yes, sir. I'll work
Did
on
you
this
catch
later.
the essence of problem?
Yeah.
Okay, good enough. Fine then. Let's keep for this day.
Yes, sir.
Okay. I presume you'll get back to me by the end of day, right?
So I will have to. I'm currently doing electromagnetic waves in physics. Once I finish that,
Okay.
I'll be studying rotational motion. Once I've covered up the theory from the ground up, everything else, I will be attempting these problems before solving anything else. So
Okay, I've written
maybe
the other
by
problem.
midday tomorrow. I will
Midday
be in
tomorrow.
college for
Okay.
the better part of the day. I will begin once I come back.
Okay. So mu is got tan theta divided by 1 plus r square by k square is the mu value.
Yes, sir.
This is what gets us to tan theta by 7 for a sphere. Correct? Yeah.
Yes, sir.
And given is tan theta by 7, half of it. Correct?
Yes, got it.
Okay. And then take care. Bye. See
Yes,
you.
sir. See you
Share the
tomorrow.
video, dear. Yeah.
Yes, sir. I'll share
See you
it tomorrow.
tomorrow.
Thank you, sir.
Right.